Hey everybody, welcome back. Today I'm going to be starting an interesting little project here. These are gauge panels for a older Honda ST1100. My brother is restoring, and what he wants to do here is take this panel that's on the right and he wants to make a mirror image of it. What he's going to ultimately do is place a little round, I believe a voltmeter in this panel over here on what I believe is the left side of the bike. I don't know, maybe it goes this way, I'm not sure. Either way, what he's looking to do is mirror this. Now, on the surface, this doesn't look like too difficult of a CAD project. We've got some odd shapes here, but we can take a picture of those or a scan of those and import those in to draw that outline. We've got a relatively or almost perfectly flat surface here. This one's warped, so we'll look at this one instead. Relatively flat surface here, but the tricky part here, as you can see, are going to be these mounting tabs. These are on a compound angle, so as you can see here, not only do they lift up and away from the part, but they're also sloped front to back. So we've got some interesting creative compound angles here, and this is front and back. The other side is basically the opposite of it. And we have to somehow determine those angles and model them so that we can put them in CAD. Now I'm not sure how I'm gonna do that. There's a couple different ways we can do this. I can try and just measure them directly using a precision protractor. We could take some different measurements and do a little bit of trigonometry possibly, or maybe even map those measurements directly into CAD. Or the third option is I may take a little, let's see if we can get this in frame, take a little indicator like this and mount it up and track along here and see how much it drops over that distance. This obviously is the hardest option, or maybe the most time-intensive option. I don't think it's necessary, but it's a possibility. So we will see what it takes to do this. The other thing I got to figure out too is how I'm going to print this. Now I can either 3D print it from the bed coming up this way, which would leave me with a nice flat surface here, or what I can do is start down here somewhere. As far as I can tell, based on this gauge, there's lots of clearance behind these things. So I may start down in this region somewhere and print up toward the top this way, which should leave him with a really nice surface finish on the top. So anyway, that's what I'm going to be starting here. And so we're going to start getting all the measurements so we can put this into CAD. Now we're doing this in metric because it's a Japanese motorcycle, and so it's interesting. I would have thought these would have come out to nice round metric numbers. I'm going to switch this over to imperial because it seems like these might actually be imperial measurements. No, just some oddball numbers. All right, back to metric. Well, off camera, I decided to go ahead and map out this part. Taking all these measurements on camera was not going to work out. So, pardon the fact that some of these measurements are not in proportion. I made a mistake when I was making the initial drawing, but I had already started with it, so I just went with it. So proportions are not right, but measurements are. We've got the upper and lower tabs there detailed. The one place where I'm going to have trouble capturing the measurement is here and over here. These are the sloped parts of these tabs. And there's just not really a good frame of reference here. So what I'm going to do, as I described before, is I'm going to put this into the mill just for the sake of having a nice solid measurement platform. And using the dial indicator, I'm going to get a baseline off of this surface, and then we're going to go measure this surface as well. And then from there, we'll be able to calculate that slope across there. The rest of these were easy to capture just with the calipers. These weren't a problem at all. So now it's just getting this final slope here for this compound angle. Just the difference between this, we'll call this top surface our primary datum, and then we'll just measure right out to the tip here. So I'm gonna go put that in the mill, get it leveled out, and then we'll take a measurement. I've got this thing clamped up in the mill, and I've got it leveled out as good as I can. I mean, this is a plastic part, right? We don't need to be crazy accurate, but I'm actually surprised at how flat this plastic is. You can see there, this is a half thou indicator, and end to end across this surface, we're actually only out by about a thou, maybe a thou and a half at the end of the day. Oh, you didn't see it. There it is. Let's try that again. It's incredibly flat, and I checked the back edge as well, and it is equally flat. Okay, so now we're aligned with the middle of those tabs on this side, and I am going to allow this to drop off and then bring it back up. I'm gonna have to stop and put my phone down. And now we can see when I'm resting right on the tip of that peg, just a few thou shy of 500 thou on this indicator. If we go back to the flat spot, so we can see we're at 700 thou. So I'm gonna call that drop off 200 thou. It's gonna be plenty close enough for this application. The final product will be plastic. It'll be slightly flexible. If we're off by a little bit, it's not gonna matter. And then on this corner, you can see we're at about 375 to 700. We're looking at a drop off of 325 thousandths. So we'll get that on paper, we'll convert to metric, and let's start putting this in the computer. I'm in Fusion 360 now, and the first thing I always do is save my projects. This helps with autosave later and for creating components. I'm going to start by plotting my initial rectangle. You'll notice that these dimensions have changed from the drawing, and that's because I hadn't accounted for the draft angle of the mold. So it actually was nice round metric numbers after all. The next thing I'm going to be doing here is creating the anchor points for the little tabs that come off the side. So first I'm going to plot the widths of them, and then using a little fancy algebra there, we get them centered in the object. Next I'm going to create some construction lines, and this is where I'm going to anchor the tips of the tabs as they stick out. You can see me fumbling with the constraints on that center line there. It should be turning black. It's centered on those other two black lines, and that should be fixing it in space. So I'm not quite sure why it's not turning black. But, oh well, this model's not that complex, so I'm not going to worry about it. You can see too that I've changed them into construction lines. That's what the dotted lines indicate. And now I'm dimensioning the centers of the two circles that will represent the holes for the screws that go through these tabs. And now I'm creating the offset circles that will be tangent to that construction line out there. These will become the tips of the tabs, the tips of the solid part. Next I create a couple random straight lines here, and I create tangential constraints and trim them out. And that results in the top projection of what will eventually be the tab. We extrude the body. Pretty simple stuff there, just extruding that initial rectangle. Now I'm just turning on the dimensions so I can see them when I'm in solid modeling mode. And here you can see I'm going to create a sketch on the side of that body. And again, we're going to create some construction lines projected off of the points that are the base of the tab that sticks out. Another sloped construction line is going to define the 2 points, or rather 2 of the 3 points that will define the compound angled plane that sticks out in space. So here I'm projecting a plane out away from that face, and that plane is where I'm going to construct another sketch that defines the tip of the slope and its dimensions. So now we have 3 points. We have 2 points along the side of the object and a third point out in space, and using the 3-point plane function we can define a plane that now sits at that compound angle. Finally, what I'm going to do is project the top sketch down onto that compound plane. I'll complete the profile and then extrude it into one of the tabs. You can see here how the tab actually isn't connected, and that's because of some interesting geometry from that projection. That's okay though, I'll just use the push-pull function to pull it into the main block. No biggie there. These dimensions aren't that critical. Same thing over here. We're just going to repeat the process for the other side, except the angles go in the other direction. I'm not really going to describe this process in too much detail because you've already seen it once, but basically the same thing happens again. We project a plane out, we create a point that defines the tip of the slope, and then we create a 3-point construction plane to define the slope of the tab. Once again, we create a 3-point construction plane at that compound angle. We project the profile of the tab down onto it, close the profile, extrude it, and use the combine function. And there we have it, the final basic shape. Now that the hard part's out of the way, in part 2 we'll go through and refine this shape. I'll show you the process of getting that curved object on the surface of it, and we'll get it ready for printing. If you learned something here, or if you like what you see, please like and subscribe. And as always, thank you for watching.